Hi, and welcome to Lesson 1.6, Tables and Graphs. So obviously, based on the title, we are mainly looking at two different things today, the idea of tables and the idea of graphs. So in order to use tables and graphs, we first have to start with the definition of data or data. So almost every day, you have had the chance to interpret data that describes real-life situations. The word data is plural, and it means information, facts, or numbers that describe something. So in math, our data can be information, facts, or numbers. Then it says, a collection of data is easier to understand when it is organized in a table or a graph. There is no best way to organize data, but there are many good techniques. Often it helps to put numbers in either increasing or decreasing order. It also helps to group numbers so that patterns or trends are more apparent. So basically what that second paragraph is saying is, depending on your data, there's not necessarily a best way to organize or display it, but there are better ways in certain circumstances depending on the situation. So for example, sometimes you might use just a simple table. Other times you may use a bar graph or a line graph or a pie chart, also known as a circle graph. So there's many different options. So we're going to look at a few of these different ways to organize and interpret mathematical data. So in example 1, they tell us the data in the table was taken from a study of what people in the United States eat. The study grouped what people eat into over 20 categories. This is just looking at the top 3 categories listed in pound per person are shown in the table. So we have our years going across the top, then our 3 categories of dairy, vegetables, and fruit, and our different data for each set of years. So our first question based on this table is, in which 5-year period did the total consumption per person of dairy, fruits, and vegetables increase the most? And then the second question is, when was there a decrease in total consumption? So in order to get total consumption, the first thing I need to do is add the columns for each year. So obviously we're not going to add the year 1970, but we're going to take the dairy data, the vegetable data, and the fruit data and add it all together. So that's where these orange numbers came from below my table. So dairy, 563.8, vegetables, 335.4, and fruit, 237.7, all added together, gave me the total for the year 1970 of 1136.9. So 1136.9. So then I did the same for each year going down the columns. So added up the 3 categories for 1975 and wrote it below it. Did the same for 1980, 85, and so on. So that's just adding the 3 categories to get my total consumption for each year. Then the next thing I want to do is to figure out the change for each 5-year period. So from one column to the next. So the way I do that, for example, if I'm looking at 1970 to 1975, I want to take the totals from those 2 years. 1970 was 1,136.9. 1975 was 1,128.2. So in that case, it went down 8.7. So I looked at the difference, subtracted, and it went down 8.7. If this number would have been larger, this would be a positive or an increase of a change. So then if we were going to do 1975 to 1980, we would take the 1980 1142, minus the 1975, 1128.2, and that gave me an increase of 13.8. Then 1980 to 1985, take 1985, the 1221.2, minus 1980, 1142, and we get an increase of 79.2. So then I did that for 1990 and 1985, from 1990 to 95, and from 95 to 2000. So that's where these purple numbers came from. The difference in each column telling me the change in those 5-year periods. So then for part A, it's asking which 5-year period had the largest growth. So I'm looking for the largest positive number out of these purples, which would be 79.2, and that was from 1980 to 1985. So our largest increase was from 1980 to 1985. Then decreases happened anywhere it went down. So from 1970 to 1975, it decreased. And from 1985 to 1990, we had a decrease. So that would be our answers there. Decreases happened from 70 to 75 and from 85 to 90. So in this case, it's just taking data from a table. Now, another way we can organize data is a bar graph. Bar graphs can be vertical or horizontal. Example 2 down below shows a vertical bar graph for the data from example 1. So in this case, if we look down at this bar graph, this is the same data from this table with the totals. Now this bar graph shows the total consumption. Now, a couple things to keep in mind whenever we have a graph. Doesn't matter if it's a circle graph, line graph, bar graph. There's a few things that are required. Number one is you're required to title your graph. So we could title it total food consumption or consumption of dairy, veggies, and fruit, whatever it may be. So we need a title to any graph. We also need our y-axis with labels and a scale for the numbers. So the label would be consumption pounds per person. Our scale are the numbers. And then our x-axis across the bottom, we also need labels, in this case year, and then the scale would be by 5 years, so every 5 years. So you need to label your x and y axis, you need a title, and you need a consistent scale going on both axes. So on the left, you can see the y-axis jump from 0 to 1,125, and then it went up by 25 pounds per person. This little zigzag means we're jumping from 0 to a number rather than putting all that blank space in our graph. So now let's look at example 2. It says, one other quick note on bar graphs, you always should have space in between the bars. Your bars should not be touching each other. So the bar graph shows the total amount of dairy products, vegetables, and fruit consumed by Americans in a given year. If we glance at this graph, it appears Americans ate 7 times the amount of dairy products, veggies, and fruits in 1995, right here, compared to 1970 right here, because roughly they're saying that bar looks about 7 times larger. But we know that's not true, because if we looked at our table, 1970 was 1,136.9, and then our other year that we're comparing it to was 1995, and 95 was 1,274. That is not 7 times bigger than 1,136. So the question A is saying, why is this graph misleading? There's a couple options, but the biggest one is because of this piece here. When we jump from 0 to a number, it's perfectly okay to do that. But because there's this huge jump and the scale doesn't go by, let's say, hundreds every time or 200s, that makes our graph misleading. So even though once we started at 1125, we went up by 25s, what makes it misleading is this jump from 0 to 1125. So in part B, they're asking, how can we draw a bar graph that is not misleading? So that comes down to the graph paper here where I drew it. Again, I added my title, added my y-axis labels, added my x-axis and labels. And in this case, what I did is I started at 0, and then each line was 100. So it went up 0, 100, 200, 300, 400, 500, 600, and so on. So every line was consistent. I didn't have a jump from 0 to 1,000. By not having a random jump in there and having a consistent scale, now you can see this overall bar graph looks much more accurate and not nearly as misleading. So that came down to that idea of the scale and not jumping. And then our other type of graph that we're going to look at today is the idea of a line graph. So line graphs are useful in many situations, but in this case, they're especially useful if we're just looking at changes of data over time, especially for one category. So example 3, they give us these two different tables that say from 1983 to 1996, average cost in millions of dollars of making a movie was given in these tables. So in 1983, the average cost to make a movie was $11.8 million. 1984, it was $14 million, and so on. So first, they want us to draw a line graph of the data. So a line graph would end up looking like this. I apologize that this got smeared a little. Joys of being a left-hander writing with gel pens. But that should say average cost in millions. So that's average cost in millions. And I set my scale. So it went 0, skip a line 5, skip a line 10, skip a line 15, and so on. So I had a consistent scale here. You could make it 0, 5, 10, 15, 20. If you didn't want to leave as much space, that's fine as long as it goes up by the same amount. And then for our x-axis, we had the years. So each line, I just put the year on the line. And then to create your line graph, the first thing you want to do is just put your dots. So 1983 at 11.8. 1983, I'd go up to roughly where 11.8 was, put a dot. Then for 1984, it was about 14 million. So I put a dot at about 14 million. 1985 was 16.7 million. So for 1985, I went up to where roughly 16.7 is, put a dot. So for each year, I just put the dot on the graph. Then the last thing you do is you go back and you connect the dots. So you connect this one to this one, then that one to that one to that one, and so on. So you first create your axes and labels, then you place your dots, and then you connect the dots with little individual segments. This allows us to visualize pretty simply what happened with the cost of movies or cost to make movies over this span of roughly 15, or not even 13 years. So we can see we have some dips where the price was going down, and we had some steeper jumps where the price was going up more than in previous years. So the steepest jump would tell me my greatest increase, but this one looks pretty close to this one, and it's hard to tell from the graph. So for question B, they're asking which year showed the largest increase. How I can figure that out, is it going to be from 88 to 89, or from this one here, 93 to 94? Well, if we go back to the table, and this is why multiple ways to organize data are helpful, I can do what I did on that first table and take the cost from 1984, 14 million, minus the cost from 83, 11.8, and I know in that year from 83 to 84, it went up $2.2 million. So then 85 minus 84, 16.7 minus 14. That year it was an increase of 2.7 million. So I just found the difference in between each set of years. So from 1988 to 1989, we went up $5.2 million. From 93 to 94, it only went up 4.4 million. So our largest increase was from 1988 to 1989. So again, what you need to make sure you do with your notes is actually take the time to create this line graph and this bar graph. That will be the most time consuming. And same thing when you are doing these. I use graph paper because it helps keep my scale the same and keep it more organized. If you're comfortable doing it on regular paper, that's fine, but my recommendation would be if you have graph paper, using that might make it easier to create your scales and to stay organized for both a bar graph and a line graph. Not a lot of notes for you to write down with this lesson. The most important parts are to carefully read through the practice problems, read through your data, and take the time to do the drawings accurately or your calculations accurately, so then you can answer based on the data. So a lot of your practice problems ask you to draw a bar graph or a line graph. Again, remember, all graphs have to have a title, have to have labels on the X and Y intercepts, and then have to have the numbers in a scale on those intercepts.